Hi guys, welcome back to my mathematics tutorial. Again, my name is Peter C. Dr. Junior, your math tutor, and I'm an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at finding derivatives of trigonometric inverse functions using trigonometric substitution method. So in the last two lessons, we solved two problems under the trigonometric substitution method. So we want to solve the third problem, which is also problem number 23 on the topic trigonometric inverse function, derivatives of trigonometric inverse functions. So now, remember we said in order to employ this substitution, you must have some fundamental understanding of the trigonometric identities because you are to do substitution. If you don't know the trig identities, you will not be able to do substitution. So what can we substitute? What can we substitute with x such that this entire expression here can lead us to some sign of something, right? Or some sign function in general. So what we know is that sine of 2 theta is also equal to 2 tangent of theta all over 1 plus tangent squared theta. This is what we know, and we can prove that. If you can just rewrite, we know that this is secant squared theta. So up here is tangent, so we can rewrite this tangent as sine of theta all over cos of theta. Divide, this is now secant squared theta. So rewriting secant squared theta, we can write it as 1 over cos. So if this is 1 over cos squared theta, and then we change this symbol to multiplication, it means that we must reciprocate. So cos squared theta goes on the top, and then 1 comes down. So what do you notice? This will cancel 1 from here. You'll be left with 1. So 2 sine of theta cos of theta is just equal to sine of 2 theta. So this is what we know. So now let's do the substitution. We say let x equals to tangent of theta. So to solve for this theta now, we have tangent inverse of x equals to tangent inverse of tangent of theta. So we need to take tangent inverse on both sides to be able to solve for this theta. So tangent inverse of x is equals to theta. Let's keep this. Now y equals to sine inverse of 2 tangent of theta all over 1 plus tangent squared theta. So sine inverse of this whole thing now is just sine of 2 theta. So sine inverse of sine of 2 theta is just 2 theta, and we know that theta now is tangent inverse of x. So we find the derivative. We have 2, 1 all over 1 plus x squared. 1 plus x squared is the derivative of tangent inverse of x. So this can just be 2 all over 1 plus x squared. This is how we find the derivative of this trig function using trig substitution method. Thanks so much for watching, and see you in our next lesson.